Good day, everyone, and thank you for joining us. Welcome to the webinar on Conference Room Design Basics. Let me introduce the team. Today's presenters are Anish Samuel, which is myself. I'm from the System Application team at Shure Middle East and Africa. Joining me is Ritendra Podar. He is from the System Application team, Shure Middle East and Africa. So, ground rules for today's webinar. Today's webinar is on BlueJeans platform. Participants' video and microphone are muted. So we would request you to wear your headphones or earphones for a better results as audio samples are being played as part of the webinar. So if you have any questions, please feel free to type it in the chat or the Q&A box, and we will answer them at the end of the session. Thank you in advance. So we are going to speak about the webinar setup that we have for today. As we are aware that many people are currently working from home, and most of our work are involving conference calls like Skype, BlueJeans, Teams, etc. We can all agree that audio plays a very important role in AV conferencing. Say if in a conference call, a video fails and audio is still there, you can continue the call. But if the audio fails, there is no way of continuing the communication. So clear audio is therefore a must for effective communication. Otherwise, joining parties need to stress a lot to listen to each conversation, which is not good, if the call needs to go on for hours and hours. It also affects the productivity and the conversation is not going to be very clear. The participants will not be able to understand what is being conveyed and will start joining the dots by guessing what was being said. So as Shure, as you may know, we have more than 90 plus years experience in delivering quality audio products. So we would like to reiterate that clear audio is a must for effective communication. To have the effective webinar, we have done our home office setup with our Shure Motive product line. So right now, I am having a Shure MV51 microphone connected via USB with my laptop. I have a headphone and a USB camera connected as well. My colleague Ritendra has a Shure MV5 digital condenser microphone, which is connected via USB. And he has a Shure SRH 145 headphone connected and a USB webcam for video. Some key features of the Motive line. The setup is very quick and it supports plug and play. No drivers are required. It is built in with a 3.5 mm headphone output. It is compatible with smartphones, PCs, and Mac. The DSP is built in, with functions like limiter, compressor, and equalizer. The MV5 has like 3 DSP preset modes, which are like vocal mode, flat mode, and instrument modes. The MV51 has 5 DSP preset modes, which is speech, singing mode, flat, acoustic instruments, and loud mode. So it can offer seamless integration with all AV applications and soft codecs, such as Skype, BlueJeans, Teams, etc. The MV5 offers flexible mounting options with its microphone's standard threading. Same goes for the MV51, which offers flexible mounting options with its microphone's standard threading. It has a durable touch front panel to ensure longevity. Moving on to today's webinar. The webinar is divided into several modules and are as followed. Module 1, a case for better audio quality in meetings. Module 2, elements of a conference room. Module 3, phases of a room design project. Module 4, planning and needs assessment. Module 5, video conferencing and remote participants. Module 6, solving common issues to improve intelligibility. And Module 7, large rooms and voice lift systems. Last but not the least, testing and optimizing the design. Module 1. A case for better audio quality in meetings. This is to better understand why audio quality can and should be improved in meetings and conference rooms. Let's look at how we can use communication in other aspects of our life. Now, communication is a fundamental part of the human experience. And as we do it continuously throughout our day, communication helps shapes the way we think, about ideas, about people, about things. So when we talk about the evolution of communication, over time, technological advancements and societal changes have shifted the way we communicate, particularly in the workspace. So meetings of today are highly collaborative and include a mixture of voice, video, and live content. So these are all shared between groups of people across the world. So today, it is quite impossible to separate our communication from the technology bit. So when we move on to the business of media and AV technology, as an industry, communication can be big business. So think about the quality of the production in sports, live meeting, or news broadcasts. These events are supported by a production staff with ample setup time and cutting-edge technology. And as it shows, the quality of the visuals and the sound design, it's very important. The impact on the audience can be huge as well. So while an average, conference meeting is actually important to the people, it still matters to a lot of the organization and those people who are conducting the meeting. The time, money, and effort are actually put into every meeting, which is directly affecting those who are involved in meetings. So what are the benefits of high quality audio in a conference room? It might be taken for granted that audio is an important part of communication. Audio interruptions, noises, and hard to hear speech can be very distracting and can easily lead to negative perceptions. So here are a few reasons to prioritize audio quality in your meeting spaces. So meetings are most productive and collaborative when each person is heard and feels like he's an equal member of the discussion. The health and well-being of employees improves when the audio is clear and intelligible. It reduces listening fatigue and exhaustion. And lastly, by enhancing your business's perception by delivering high quality meetings, where everybody is clearly heard and understood, even on the far end of a video call. So how do we measure speech quality? It is important to realize that sound quality is not an absolute term. We had this discussion in our previous webinar as well. It depends on the context. So what comprises of good sound will be different from music as opposed to speech. So it is your intuition. As your intuition may tell you that, all you need is a good sound. All you need for a good sound is accurately, pickup and reproduction. But the truth is actually, success in audio is defined by the situation and the context. The speech intelligibility, can be actually measured by STI or speech transmission index. The STI measures the speech transmission quality, which consists of several aspects of a scenario. So it can be a mixture of speech level, frequency response of a particular channel, background noise level, quality of the sound reproduction equipment, presence of the echo and reverb, and psychoacoustic effects or masking effects. So these ingredients result in the intelligibility of the audio in a very given situation. And later on, when we look at testing and optimizing your installation, we can look at acceptable ratings for all these environments, such as, meeting and conference environments. So moving on to the next slide, while we are designing for the room for intelligibility, we need to make sure that the room is a very critical factor in audio quality and meeting performance. It is as shown by the characteristics measured by the STI for speech intelligibility. A well-designed room, provides the ideal environment and set of tools to provide intelligible speech for meetings. This is especially important to the integrated systems market environment. You need the CEO's speech, for example, to sound great, and you want the learners to fully understand each of the education sessions. To achieve this, anything that interferes with the clear speech and listening needs to be minimized or eliminated. So there are several competing factors at play in a conference room. Competing interests such as room aesthetics, function and money, etc., etc. Challenges can also be introduced by the number of participants, the layout of the room, the activity, and the needs of a sound system. So whether or not a video calling is required, etc., etc. The list can go on. So in addition, the acoustic characteristics of the room have a significant impact on the sound of the speech and the resulting design of the AV system. So this particular webinar, provides you an overview of these and other important considerations to make when you are designing a room for meeting and conferences. So we move on to module 2, which is elements of a conference room. So for this webinar, we are focusing on what we call as a conference room. The conference rooms are in fact meeting rooms which are common in most organizations and corporations. The conference rooms provides an AV or audiovisual system that brings together speech, video, and screen sharing between participants. The conference rooms are the place where technically complex and collaborative communication is possible in a simple and natural way. Moving on to the scale and complexity. The term conference room in this particular webinar covers other more similar terms like boardrooms, huddle rooms, and collaboration spaces. So really when it all comes down to the need of the room, that's when you identify whether it is a simple or a complex kind of setup. So when meetings are small and simple, they don't require anything too special. Perhaps a group is reviewing a document, or they need isolation to focus on an issue. In this particular scenario, just the basic requirements of the room are like good acoustics and an acceptable ambient noise level. As meetings become larger and more complex, the room requires additional resources to keep the collaboration natural and efficient. The many medium-sized rooms include video or teleconferencing to connect remote participants. So this in effect creates a large audio system comprised from the two locations. So additional care is required, and tools are required for effective audio experience from both ends. So sometimes even the room itself is large enough, and an in-room sound reinforcement system is required so that the people in the room, sitting apart on both, the near and far side of the room can hear properly. So this is referred to as a voiceless system, and we can use a zoned speaker system to provide enough boost to hear everyone in the room. Now let's talk about the common elements of a conference room. Most obvious is the functional furniture, that is centered, within a room, or, mostly the tables, chairs, and the display orientation. So the layout of the room is very important as well, and it will also affect the decisions in a room. And also you have to consider the acoustics and the AV system design. So most rooms can include an AV system also to support video, phone, or web calls, screen sharing and media playback and other collaboration tools. DSP or digital signal processing, codec, and networking are also included for fine-tuning the audio and integration with IT services and support. Ideally to an end user, a meeting participant, the system should be very easy to operate and it should deliver consistent results. And lastly, all the rooms should have a degree of interior finishes. So whether it be carpeted floors or like, drop ceilings or sound absorption panels, well-planned rooms can give you success, and also it can incorporate, acoustical treatment inside the room, and also it can aid in the aesthetic design of the room. So we are looking at some acoustical finishing, options later on, and we'll discuss tips to improve the sound within a room. Now we move on to an example AV scenario. Though the exact details of each AV system could vary, room to room, there are some common AV components that can be found in most rooms. First we have the microphones used to capture speech within a room. So for this particular example, we have the MXA 910, ceiling array microphone, which has 8 independent, steerable channels. This is connected to a network switch supplying power over Ethernet to the microphone. The switch is connected to a P300 audio conferencing processor, which is connected to the AV device and providing DSP processing as well. A laptop is also connected to the P300, which is running a video conferencing web app with a soft codec. An optional 3.5 mm connection is available on the P300 DSP mixer, in case you want to connect to a remote caller. So all these signals are processed and connected to the video conferencing codec and loudspeaker for in-room reinforcement. So moving on to the next module, the phases of a room design project. So there are many considerations when designing an effective conference room. There is a general process that most projects follow. And let's walk through all these phases. The phase 1 is needs assessment. So performing a needs assessment is the first step, and it is also deemed as the most important one. So we'll be spending some extra time on this, as soon as we get the project overview from the client. So the needs assessment provides the direction of your project by determining the real needs of the users. It is balanced against the real constraints of the project. So the real users balanced against the real constraints. Bear that in mind. So it is very important that we don't be discouraged in this step because it can feel a little bit tedious. So a careful and thorough needs assessment will be provided, in order to get the best data to create the room design with utmost accuracy. Moving on to the design phase. So the design phase takes the information gathered in the needs assessment and puts together the plan in much detail, So if this is a completely new room, the design may include aspects of the physical room to improve the acoustics from ground up. Other rooms may only require like a simple new microphone, and the scope of the design would be, following suit. So there are two different parts this particular project may go down with, beginning with the design. So one is the audio consultant route, and the second is the integrator route. So when you are the audio consultant, there are 3 steps: design, bid, and build. So the extra step of the bid is included in when you are an audio consultant. Since the designer is a consultant and he doesn't act as an integrator, he needs to bid it so that qualified integrators get the job and execute it as per the customer requirements and the specs. So the integration route. So integration, it is more or less a design and build project. So it doesn't have a bid component. And since the designer also acts as the integrator, he buys, installs, and optimizes the equipment. So moving on to the bidding and contracting phase. The bidding phase actually includes the review and selection of the integration proposal based on the specification. Moving on to the next slide, fabrication and programming. Okay, so in this particular step or phase of the project, the integrator begins assembling the build as per the design specification. The equipment is purchased and assembled off-site, to do as much setup, programming, and testing, whatever is possible. The next phase is called installation and tuning. Once the room is ready, it is time to install the audio equipment on site. So this includes installing each device, connecting the system and testing the audio. So it's important to test the system with real people organized in a realistic setup, in order to make accurate adjustments. The next phase is called sign off and completion. As the project nears the end, the integrator will actually provide operational instructions and handover of any project assets, such as default room settings, default room settings that meet project specifications, templates or scenes for specific functions, any additional training or user guides or operation manuals, etc. It's part of the handover doc. The last phase is support and service. Some projects include like a service contract after the installation to continue helping the client maintain and support the rooms. So this can take many forms, like it can be maintenance or phone support, contracted staff being on site to support the client, or troubleshooting visits, or you can have any kind of an SLA based arrangement. So to summarize, this gives us a good idea of the lengthy and collaborative nature of a room design project. This is just to make sure that the project goes well. Let's look at some ways to get the best data for starting the project. That is the needs assessment. Moving on to module 4, planning and needs assessments. So before taking any other step, it is important to identify the client needs and the requirement for this space. So any additional decisions, money and time spent should be used to reinforce these needs. So, effective study of the room, the surrounding space, the IT infrastructure, the AV technology and tools, it all should be studied properly. So there are 3 steps for a successful assessment. We are going to cover these 3 steps. First is investigate, second is interview, and third is educate. So step 1, the investigation. So you need to do your homework. So start with the research, The goal is to understand the real needs of the new conference room. So this can include the current facilities and meeting spaces, equipment, tools and services, culture and behavior of the organization that you're catering to. And, our meetings are more formal or informal within that organization that you're going to support. And you need to take the, stakeholders and key collaborators and, investigate on what is their mode of, presentation and stuff like that. So this can actually include observing a real presentation or meeting in their, environment. So what are the meeting space like and how are they being used? It can definitely support you further. So which AV tools are installed already and what are they functioning like, or is it functioning as designed? So is there any dedicated AV staff, or do the participant or their IT team directly do the setup and troubleshooting? So you need to check all of that. So all these questions, they can provide insight into the project and the people whom you are working with. So step 2 is the interview. Now you need to play the detective. So it is actually human nature to think that we know what we want exactly. Especially early on a project, it can be very tempting to think about solutions rather than, looking at all the options. So a good way to get past this is actually using interviewing techniques, with the client and the end users. So this is, actually deemed to be a very fun, excuse to play detective or interrogator to get the answers that you need to design the project. Here are, we are going to discuss a few tips to get you interviews to actually get what is the user's real needs and common applications and behavior within a project. So step 1, you need to talk to the real end users. So as you begin, asking the tough questions, if the interviewee doesn't know the answer, make sure that you get the person who does know the answer. Eventually this will lead you to the real stakeholders that will benefit the most from a good room's design. Step 2 is to avoid interrupting or hurrying through the interviewing. Sometimes the awkward moments that, can happen during an interview phase, it can actually lead you to a more insightful data that can further help you in your design. Step 3, if possible, record the interview and document the interview. So comments, actually make a very powerful data when backing up design decisions at a later stage. And step 4, you have to be respectful of the interviewee's time, and you must do as much research upfront as possible. So remember, they are taking time out of their valuable normal day for you, and you need to respect that. The third step is to for needs assessment is to provide education and teach the masses. To complete the assessment, follow up with stakeholders and walk them through your findings. You need to reinforce it with relevant information from AV conference systems, or room acoustics and industry's best practices. You need to educate them. So as the audio expert, you can provide valuable considerations and real world knowledge that the client may know very little about. So during this time, you can provide data to reinforce your proposals, calm fears related to audio networking technology, correct misleading or incorrect assumptions, talk about the new technology and design ideas. So as we have discussed, the needs assessment is an integral or an valuable part of a room design project. So however, it requires care and time to make sure that you have understood the client's need. So using the 3 steps, investigate, interview, and educate, you can help extract the information that you need in providing a successful design. So we move on to module 5, which is video conferencing and remote participants. So I'm handing over the floor to Mr. Riten. So he'll be taking you through the rest of the modules. If you have any questions, feel free to ask in the chat window or the Q&A window. Thank you for your patience.
Thank you, Anish. Thanks for sharing your great knowledge and experience. Now let's move to our next topic. Hello, everyone. I'm Riten, Systems Application Engineer from Shure. As it was mentioned earlier that we're going to have a lot of audio demos in this webinar. So please wear the earset or headphone to have the better experience. I would suggest to keep the volume level up at somewhere around 75 to 90 because we're going to have off-axis audio demo of the microphone, so you need to hear it clearly. Okay, so let's move on. So let's start with the video conferencing. Video conferencing is a powerful way to enhance communication with others in different locations. It requires additional considerations like microphone selection and positioning, codec, and far-end limitations. Talking about near-end, far-end, there are 2 subjective terms to define the system. First is the near-end. Near-end is basically a room the meeting is hosted, so the call is going to start from there. And the second is far-end. Far-end is the location of the remote caller. Multiple participants, then all the attendees are going to be the remote caller in that case. So it is an important part to have the right microphone selection, right? In this course, we will go through a few of the microphone basics at high level, and we'll give you the listening examples and discussion during this case, right? So let's start with the microphone characteristics. So I'm just going to go through with the microphone characteristics. So there are a few characteristics to consider when choosing the microphone. The first one is the frequency response, and the second one is directionality. So frequency response defines the range of sound that a microphone can reproduce and how its output varies within that range. The frequency response is one of the most significant factors in determining the sound signature of the microphone. The frequency response of a mic is represented graphically by a response curve with a range of 20 Hz to 20 kHz. And there are 2 most common types of frequency response. First one is the flat response, and the second one is the shaped one. Shaped one is also called as tailored frequency response. The second important microphone characteristic is the directionality, also called the polar pattern. So the directionality determines how the microphone responds to sound from a different direction. The 2 main types are omnidirectional, also called as omni, and unidirectional, or simply directional microphone, right? All the microphone in this course discuss directional polar patterns, since we are less concerned about the fidelity that comes with an omnidirectional microphone and more concerned with only pick up speech while rejecting distracting ambient noises. Unidirectional microphones have maximum pickup in one specific direction called on-axis, with increasingly less sensitivity at sound source gets further off-axis. Now let's look at common microphone design and their advantages and disadvantages in the conference room. So I'll start with handheld microphone. So as we already discussed in our previous webinar about the different form factors, so I don't just want to give you the same info. I'll give you the audio. I'll share the audio samples and we'll demonstrate the audio quality with the microphone. So handheld microphone is useful for presenting and performing. It can be held in hand or you can place on the stand, right? Now, in this slide, I am just going to demonstrate the audio sample. So the demo has been done with Microflex wireless handheld microphone with the cardioid polar pattern with SM86 capsule. And as it is the directional polar pattern, so sound will vary with the distance. So just bear with me. I'm going to play the audio demo. Please wear the headphone to have the better experience of the demo.
This is a sample recording of a Shure MXW handheld radio microphone with an SM86 capsule, which has a cardioid pickup pattern. This microphone is most sensitive directly in front of the capsule. It's less so at 45 degrees off axis, even less at 90 degrees off axis, and the most rejection at 180 degrees off axis. The microphone is also sensitive close to the sound source and ever less sensitive the further away it becomes. The microphone is now arm's length away from my mouth.
Great. Hope you understood how exactly the polar pattern behaves if the microphone is away from the talker in different angles. Now let's move on to the next one, boundary microphone. Boundary microphone offer discrete and low profile. It can also have optional mute button and LED indicators, right? And it can cover multiple participants. We recommend to have one microphone with one participant. It can be shared as well if the budget is the concern. So let's move on to the audio sample of boundary microphone. So the audio has been recorded with our Microflex wireless boundary microphone MXW6 with cardioid polar pattern. Microphone is great, but there are some kind of limitation which you need to consider in this kind of form factor. It can pick up the table sound. It is going to be on the table. It's a tabletop microphone. It can pick up the sound from the table, keyboard, mouse, or paper rustling on the table, right? If in case you are having a laptop in front of the microphone, so laptop can block the mic and reduce the high end frequency. So your sound is going to be somehow muffled, not very clear. So let's move on to the audio demo. I'll play the audio demo again. Just bear with me.
This is a sample recording of a Shure MXW boundary microphone with a cardioid pickup pattern placed on a table at arm's length. The microphone is most sensitive directly in front. It's less sensitive at 45 degrees, even less at 90 degrees, and least sensitive at 180 degrees. As the mic is placed on the table close to other objects, it can pick up sounds from keyboards, mice, and other unwanted noise, such as paper rustling. Another issue we see with boundary microphones is when room users put their laptops between themselves and the microphone and raise the screen, which cuts off the high-end content. An example of this is if I raise my laptop screen to obscure the microphone from my voice, you can hear that the high-frequency content is now lost. As soon as I close the laptop screen, the full audio spectrum is restored.
Great. Hope the demo clarifies the way microphone works. Now let's move on to our next slide. That's all about gooseneck microphone. Gooseneck microphone provides good gain before feedback, as the microphone is going to be closer to the talker because of the stem. It reaches over the laptop and books because the stem of the gooseneck is going to take care of the capsule to come closer to the talker, and you can have mute button and light ring indicator with such microphone. So talking about the audio demo, I'll take you through the audio demo of our Microflex wireless gooseneck microphone MXW8 with cardioid polar pattern. The benefit of having the gooseneck microphone is it can be away from the table noise. It can come closer to the talker. It is having some kind of consideration. Basically it is affected by the head turning. So if you move your head, if you're going away from the directionality of the polar patterns, yeah. And the other thing, what we have noticed in most of the meeting environment, that people, as it is closer, people tend to play with the gooseneck, and that is also getting picked up with in a conference call. So let's go through the audio demo of gooseneck microphone.
This is a sample recording of a Shure MXW gooseneck microphone with a cardioid pickup pattern. It's placed on the table in front of me at arm's length. It's most sensitive directly in front, less so at 45 degrees, even less at 90 degrees, and least sensitive at 180 degrees. As a capsule is away from the table, it will pick up less noise from a keyboard and a microphone compared to the boundary microphone, but it does suffer from, as I turn my head away to talk away down the table, the sound tonality changes. Another phenomenon we see with gooseneck microphones is room users tend to play with them or interact with them with no regard to what might be heard at the far end.
Okay, now let's move to the microphone which solves all these problems. Yeah. So the next type of the microphone is array microphones. Array microphone offers non-obtrusive design with mounting completely off the table. It offers steerable coverage with 8 different polar patterns to aim the audio coverage. You can have multiple channels, and that can be turned on and off with the IntelliMix built in with the microphone. Right? Going forward, let's have the audio sample of array microphone. I just want to emphasize over here that as it is away from the table, you will be having less noise of the table, and there is no such issues of user adjustment because it's on ceiling. Yeah, and it's also less impacted by head movement because the lobe is always going to cover you regardless of how far you go in that lobe area. Right? So let's go through the audio sample of MXA 910.
This is a sample recording of an MXA 910 mounted at a height of 2.39 meters in a room which is 5.2 meters by 7.4 meters. There's one wall of glass, one wall of windows with the blinds closed, and 2 plasterboard walls. There is also a boardroom table and leather chairs. The sound in this room is acoustically dead without being unnatural. The MXA 910 is configured to use one narrow lobe, and I'm sat approximately 1.5 meter from the mic. EQ and noise reduction is turned off.
Great. Now, hope it clarifies the way the microphone picks up, right? Now, let's move on to the next slide. Critical distance. In this slide, you see that the microphone is dependent on the critical distance. And what is critical distance? Let's talk about this. Whichever microphone you choose, make sure to position it correctly for the best result. The critical distance is the distance at which the direct sound from a speech and the ambient noise and the reverberation are of equal intensity. Remember, it's on equal intensity. Yeah, beyond that distance, the microphone no longer picks up enough and doesn't sound intelligible for a speech level, right? To estimate the critical distance of a microphone and the surrounding environment, we use an omnidirectional microphone to determine our starting point and give this value as 1. Okay, in this slide, omnidirectional has given the value of 1. As the microphone pattern becomes more directional, it increases the value. Since a directional microphone by nature rejects sounds outside the pickup pattern area, as cardioid microphone has a critical distance 1.7 times the distance of an omnidirectional microphone from the sound source. When the Shure MXA910 ceiling array microphone is set to a narrow width, it has a value of 4 due to its highly directional lobe pattern. Okay. Now, talking about the codec, it is important to know how codecs affects the streaming quality of the video and audio signal. A codec is a device or application for encoding or decoding a digital data at both ends of the call. Remember, a codec is a combined word of encoder and decoder, is required for the real-time transfer of audio and video between rooms. Different codec standards exist, and the best standard shared between the rooms is chosen. As mentioned earlier, this means that even if one room has the best hardware codec, it will be forced to select a lower standard depending on the connecting call, right? So codec plays a very important role and its quality as well. Now let's move on to the next topic, and the topic is solving common issues to improve intelligibility. Okay. There is a saying in audio industry, don't wait to fix it in the mix. This means that there are many steps along the way to a recording, and identifying and fixing problem upfront will make everything easier and less costly to fix down the line. This also applies to a room acoustics in conference room performance. While it may be tempting to buy a different microphone or more expensive processors, DSP processors, the best investment you can make is into improving the acoustic of the room upfront. Making a positive change at the beginning of the signal chain impacts the entire system performance. So no need to wait to fix in the mix. You can work on treating the room properly, and that can help a lot. And then you hardly need to look on the DSP processing. So there are 4 ways to improve the room performance, and I'm going to talk about this. So first one is the acoustical theory. Second is interior finish and treatment. Then the third is to reduce the ambient noise of the room. And the fourth, the last but not the least, is digital signal processing. By the way, if you take care of first 3 parts of improving the room performance, you hardly need to work on DSP side. Acoustical theory, interior finish, reducing ambient noise will help a lot. So it's just a matter of routing the audio and do some kind of little adjustment in digital signal processing will do the job. So let's talk about the first one, design with acoustical theory in mind. You have to follow these acoustical design and tips. First, avoid parallel surfaces. Parallel surfaces creates the standing waves and it creates the reflection. So that affects the intelligibility of the microphone pickup. Use dense building material that limit outside noise. We have seen many meeting rooms where the end user is having issues listening the ambient noise, listening the outside noise in the room. So having the dense building material can help in that. Limit reflective surfaces. For example, hardwood or glass walls, hardwood like reflective tables and chairs. Limit that, and that can help in improving the acoustical part of the room. Now, talking about acoustical issues, the biggest challenge and the issue is the reflections. And reflections are particularly a problem in the conference room, and it happens because of layout or maybe the aesthetics. So talking about the layout, table and hardwood surfaces can create the reflection. Large marker board on wall can create the reflection. Existing electrical and network infrastructure as well. In terms of aesthetics, glass walls and windows creates reflection. Non-absorptive ceilings decorations, concave walls, and ceiling as well. So I'm just going to give you a demo of a noisy room, which is having a lot of reflection, and the audio has been recorded with our MXA910 ceiling array microphone. Let's listen to it.
This is a sample recording of a Shure MXA910 ceiling array microphone. It's mounted at a height of 2.39 meters. The room I'm in is 5.8 meters by 3.73 meters. It has 3 walls of glass and 1 plasterboard wall. There are minimal furnishings. As you can hear, the sound is quite reverberant. The mic is configured to use one narrow lobe pointed at me, and I'm sat approximately 1.5 meters away from the mic. EQ and noise reduction are both turned off.
Great. Now let's move on to our next slide. So having the interior finish for the room treatment, examples like carpeting, acoustical ceiling tile, hanging baffles. Hanging baffles are in trend nowadays. Many acoustical consultants are choosing this type of ceiling, what you see in this slide. It looks nice and it improves the acoustical situation of the room a lot. Having the movable partitions with the acoustical material, acoustical foam, seating and furniture with the soft absorbent material helps a lot to treat the room in terms of acoustic. So let's listen to another audio demo where the microphone is going to be same, but the room is treated. So that will give you a kind of idea of what exactly you can do if you treat the room acoustically. So just bear with me. I'm just going to play the audio file.
This is a sample recording of an MXA910 mounted at a height of 2.39 meters in a room which is 5.2 meters by 7.4 meters. There's one wall of glass, one wall of windows with the blinds closed, and 2 plasterboard walls. There is also a boardroom table and leather chairs. The sound in this room is acoustically dead without being unnatural. The MXA910 is configured to use one narrow lobe, and I'm sat approximately 1.5 meter from the mic. EQ and noise reduction is turned off.
Great. So I hope you understood what exactly you can do by treating the room, and audio samples justify that. Now, this slide is about style with function. Nowadays, interior designers are well educated and they know what exactly can happen if you treat the room properly for such kind of meeting room, boardroom, and conference room. To show you some examples here, in this slide, picture number 1 is showing the wall with acoustical panel. Looks nice, right? And it is also solving the acoustical purpose of the room. The second picture in the middle is showing hanging acoustical panel. If you see just without thinking about it, it looks like a designer ceiling, but that is also managing the acoustical condition of the room and absorbing unnecessary reflection. The third picture, what you see here, is hanging baffles. Hanging baffles looks nice and it's helping a lot in absorbing unnecessary reflections and reverberation. Right? Now, let's move to the next topic about reducing the ambient noise. There are common items that adds to the noise floor in a conference room. For example, heating, ventilation, and air conditioning, Hvac noise, projectors, fan, that can be noisy as well. AV equipment, if the rack is placed in the room itself and that's having fan and all, that can add ambient noise. Computer typing, people rustling, outside traffic, construction, or other activity can also be the part of the ambient noise. So now it is very important to manage these ambient noise, to reduce these ambient noise. So I'm just going to talk about a topic over here that's called noise criteria. To better understand ambient noise and the noise floor, we look at one of the most common standard, the noise criteria. So noise criteria or NC curves are a standard for measuring noise floor, also called background noise in a space. The value produced can be equated with averages of common places. For example, if you talk about recording studio, which is designed with even more precision and care, is rated around somewhere of 15 to 20. Restaurant range is somewhere around 40 to 45, and conference room fall in between around 25 to 30. It's very hard to have 25 to 30, but still, if you can manage to have the meeting room, conference room at 40 to 45, you're safe. Your room can have better audio intelligibility by applying a couple of audio processing blocks. Now, talking about Hvac system, we mostly think that Hvac system produce the low frequency that is basically happening with the Hvac system. But no, Hvac system also produce high frequency. So low frequencies are caused because of the mechanical noise of the system, and high frequency is because of air speed and all. So what is the solution to eliminate the low frequency from the audio system? You can apply low shelf EQ, you can apply noise reduction in DSP, you can limit the open microphone. Having more microphone open means that you're adding a lot of ambience to the system. Having less number of microphone open will help to improve the intelligibility. Talking about high frequency, you can also manage high frequency by applying high shelf EQ, use array or directional microphone. Directional microphone will be having the narrow pickup that will try to reject unnecessary ambience of the room and gives you better intelligibility. Now, let's have an audio sample of Hvac, a microphone recording which is with Hvac on and Hvac off, right? So just bear with me. I'm just going to play the audio sample for that. 1 second.
One lobe of MXA 910 with air conditioning off. One lobe of MXA 910 with air conditioning turned on.
Okay. I'm sure it was clear enough to notice that what happens if the Hvac is on, it adds the necessary airflow in the microphone that is not acceptable for a conference call. So now let's move to the next way of solving the acoustical things of the room is with the digital signal processing. Yeah, this is the last method what you can apply if your room is having acoustical challenges and you can't manage those things like reducing the ambient noise, helping in reducing the reflection and reverberation. Then you need to deal with the digital signal processing. As we discussed DSP processor blocks in this slide, we are going to demonstrate the audio quality, what you can have after applying the audio processing in the DSP blocks, right? So the first thing is gain and gain structure. Gain is basically the adjustable level at the input stage of a device. Maintaining appropriate gain structure is essential to create a good sounding audio system. Poor gain structure can lead problem and noise issues, including artifacts and distortion in audio signal. So I'm going to give you a few tips to keep it in mind when adjusting the gain. First, what you need to care is aim for nominal levels. Starting with the mic input all the way through the endpoints, loudspeaker. Gain must be considered at each device in the signal chain. Too much gain leads to distortion, remember that. And not even enough gain leads to poor performance of EQ, noise reduction, AAC processes. Yeah, gain must be considered every piece of equipment in the signal chain. Okay, now let's move to the next, equalization. Equalization or EQ is useful for reducing and boosting frequency in a given channel or mix. I'll give you a few tips for best result. Please keep these tips in mind when EQing a signal. Okay, first, cut or reduce first. Then, if necessary, make any boosting adjustment. For example, like if your room is noisy, so first cut the low end and high end. And then if you feel like the audio is not clear, so you can play with adjusting the low end or mid-high. Mid-high is mostly recommended because that's more on the audio intelligible frequency of human voice, right? So the human voice mainly reside between 200 to 8,000 hertz with a speech clarity around 1K to 5K. Yeah. EQ is effective for reducing low-end Hvac, mechanical vibration, and high-end Hvac air noise. Okay. Now I'm going to play an audio sample here to make you understand how exactly EQ works when you are having such situations. So bear with me. I'm going to play that audio sample.
One lobe MXA 910 with EQ contour off. One lobe of MXA 910 with EQ contour high pass. One lobe of MXA 910 with EQ contour low shelf. One lobe of MXA 910 with EQ contour multiband. One lobe of MXA 910 with EQ contour off.
Okay. I guess someone is having microphone open. That's creating the unnecessary noise in this webinar. So please mute the microphone. Okay. So now let's move to the next audio block. That's AEC, acoustic echo cancellation. So the next audio block is AEC, acoustic echo cancellation. We are having issue with the audio. Somebody is.
Sorry to jump in. Muhammad Abdo has his microphone on. Can you please mute your microphone?
Sorry, guys. Please mute your microphone if you're having the microphone open right now. That's affecting the quality. Okay, so now let's move to our next audio block, AEC, acoustic echo cancellation. To understand that, first we need to understand what is echo. So I'll give you a simple example. If you're in a conference call, you're speaking in front of the microphone, the audio goes through the conferencing codec to the far end, and at the far end, you're gonna have the audio, the far end listener will listen your speech or audio through the speaker. And if the microphone is closer to the speaker, the microphone will pick your audio and then it will be sent back to the room, to your room. And then that will be played by the speaker. So you hear your voice with some latency. That's called echo in a conference call. So how to solve that? Solve this, you have to have AEC in your DSP processing. So AEC is having the option to give the reference of your far end output. You give the reference, the microphone, the DSP block will understand, okay, I don't need to listen this, whatever is coming back to the system, and it just cancel that out. So that's AEC. So let's have a look and listen to the audio demo of the AEC block, what happens when you're on a conference call and how to solve this, okay? So let's listen to the audio sample.
This is a sample recording of the echo cancellation process within P300. I have a far end participant on this conference call with echo cancellation turned off. Hello.
Hello from the far end. Oh, I can hear myself. This might be a little bit difficult. Can we try and fix this, please?
Now I've enabled the echo cancellation process in P300 and you can no longer hear the far end participant in my microphone feed.
So let's try this again. Okay, yeah, this is a lot better now. I cannot hear myself, so we can have this conversation with a lot more ease now.
Great. I hope that clarifies what happens when you have the room is having echo and how exactly it can be solved. Now let's move on to the next audio block of the DSP, that's noise reduction. Noise reduction determines which frequencies are constantly present and eliminates them from the signal. It leaves the room for transient changing frequency, which is speech. Noise reduction is particularly helpful for reducing Hvac background noise. So I'm going to play the audio sample in a noisy room environment, and then please listen at how exactly the noise reduction can reduce the unnecessary noise of the room. Okay, bear with me. Sorry, some kind of glitch.
P300 noise reducer off. P300 noise reducer set to low. P300 noise reducer set to medium. P300 noise reducer set to high. P300 noise reducer set to off.
Great. I'm sure you noticed the difference when the noise reduction is on and when exactly it is off. Yeah, we are very proud of our noise reduction AE, what we offer with our Intellimix P300 DSP. Okay, now let's move to the next audio block, that's auto mixing. So automatic mixing basically helps reduce noise by turning down or off unused mic in the room. This ensures more gain before feedback and lower noise floor. In our DSP sample, let's listen to the automatic mixing applied to our MXA910 with 8 channels of audio. So I'll play the audio sample again.
This is an MXA 910 with 8 open lobes summed together as a single output. This is the same lobes from the same MXA 910 run through a gated auto mixer with 1 open lobe and all unopened lobes at minus 25 dBs. Back to manual mode with 8 open lobes, no auto mixing.
Great. Now let's move to the next slide. And here we are going to give you the complete experience of having the audio processing blocks. So I'm going to play another audio sample.
I'll now demonstrate how adding each process in turn can radically improve intelligibility in this microphone pickup. The first thing I'll do is turn on noise reduction for each lobe. Already you can hear that the sound is much clearer. I'll now engage the auto mixer to highlight one lobe and suppress 7 others. Even more background noise has now been suppressed and my voice is much clearer. Finally, I'll add some parametric EQ to shape the tone to sound as I like it. I've added low end to bring body back to my voice and cut out some of the super high frequencies to minimize sibilance. You can now hear that this is a very clear and comfortable audio signal to listen to on a video conference.
Okay, so I hope you understood, you learned what exactly you can do with the DSP by applying different audio blocks. For best result, working with acoustical consultant helps a lot. Whenever possible, a professional acoustical consultant will provide a valuable input to the architectural design of the room. Tip, early involvement is the key. Again, early involvement is the key. If the room is ready, everything is done, furnitures are placed, wall is designed, then it becomes quite challenging to treat the room. And then you just need to rely on the audio processing DSPs. Yeah. Now, let's move to the next topic, large room and voice lift system. If you're having a large room where the participants are sitting at distance, so it will be very hard for the listener to listen to the talker who is sitting almost 20, 30 feet away from the talker. Yeah. So for that kind of room, you need to look on the voice lift system. Let's talk about how does the voice lift work. Voice lift, it's basically a sound system that provides just enough sound reinforcement in a room so the farthest listener can hear as well as the closest. Yeah. Voice lift is nothing but it's just the compensation for natural loss over the distance. Yeah. It increases the intelligibility with minimum amount of gain. To achieve this, you have to have a proper speaker zones. You have to have multiple speaker zones to have more controls on your output. In this particular side, as you can see that there is a talker who is speaking with the Gooseneck microphone and the speaker next to her is off. And it's practical, right? If the listener is sitting just next to the talker, you don't need to listen through the speaker. The listener can easily listen to the talker without having any technology involved. Now, talking about the farthest listener who is having a speaker and that speaker is on. Why? Because over the distance, the intelligibility and the sound pressure level will reduce up to some extent, and the difficulty is going to be there for listening by the audience. So at that point, you have to have the speaker on. Having more zones can help to maintain the mix minus properly, right? So mix minus is the key for having such kind of system. More zones, less feedback. What does it mean is you have to have, if you're having more zone, you have more control on the speakers and you can easily do the mix minus to have the proper outcome from the system. When we say zones, it doesn't mean that one speaker requires one zone. You can have a group of speakers all together as one zone. The only thing what you need to remember over here is whenever your specific microphone of that specific zone is on, you should keep the zone speakers of that zone off or at very low level. So that helps to have the voice lift system. We have our Hvac calculator tool on our website. It helps a lot to understand what exactly and whether it is possible to have the voice lift or no. The minimum distance from the talker to the listener should be at least 25 feet for applying our ceiling array microphone to do the voice lift, right? So if you're having questions in your mind whether the microphone, our ceiling array microphone can do the voice lift or no, we recommend to go to this tool and enter all the values. For example, number of open microphone, talker to farther listener, microphone to loudspeaker, and it will give you the calculation of potential acoustic gain and needed acoustic gain. It is always going to have, you should have potential acoustic gain higher than the needed acoustic gain. Then only you can do the voice lift. So the calculator gives you the value in 3 different colors, green, orange, and red. Green means okay, you can do that. Orange means possible, but yeah, you need to look on that. But red, it will not work at all, right? So that can give you an idea what exactly you can do with different microphones. Now, the next topic is testing and optimizing the room design. Okay, so we always recommend to have the sound check. When you are configuring the system, everything is ready, you are on site. So we always recommend to do the sound check. Sometimes you will be having a situation where you'll be blamed for your system saying the audio is not sounding good, right? So at that point, it is always good to have the sound check. You can have, suppose you have ceiling array microphone or Dante based microphone, you can use Dante headphone amp to route audio directly from the microphone and you can listen through the headphone. So that eliminates at least one point where you can say my audio, whatever is coming from the system, is clear. Now the issue can be somewhere else. So over there, we recommend to have the listening at various points in the signal path. So if microphone is giving crystal clear audio or acceptable audio, intelligible audio, then it is always better to listen to different layers. For example, pre-mix, in DSP, post-mix, or the signal, whatever is going to go to the video conferencing codec. Yeah, so that can justify the problem where exactly it is, and you can easily troubleshoot that. You can also do STIPA test to understand the intelligibility of the room, right? So what is a STIPA? STIPA is Speech Transmission Index for Public Address System. It is an intelligibility rating for meeting room, conference room, any kind of audio, any kind of space where you want to run the audio system. So the scale of STIPA is in the range of 0 to 1. 0 means bad, 1 means excellent. Meeting room, boardroom, conference room falls under the range of somewhere around 0.64 to 0.68. Talking about recording studio, which is the best room, which is going to be the best room for any kind of audio system for recording and any other kind of stuff. So that requires the STI range of 0.76 or higher, right? You'll be amazed to know that if your room is acoustically treated and you use our MXA ceiling array microphone, it offers you STIPA A in that situation, right? So how do we measure the STIPA? To measure the STIPA, you have to have the audio tool which can measure STIPA, and you need to run STIPA test tone. So STIPA test tone is not the human voice, but it is having all the frequency ranges what falls under human voice range. Okay, so you play that and then that gives you the value accordingly. So I will just play the last video, which audio, which will give you the experience of STIPA test tone. Okay. So this is the STIPA test tone, and that you need to play to have the STIPA rating. Now, that's all about it. We are done with all our modules. So in this course, by now you should be able to know about basically describe common elements of conference room, overcome common challenges of AV conference room design, identify with and work with key collaborators, perform a need analysis to identify requirement and needs of the client, identify solution to improve his speech intelligibility in a conference room. Yeah, so that's all about it. Hope this course was informative and you guys can apply in your system design, and stay tuned for our next webinar, which is going to be next week, same day, same time, from same place at my home office. Yeah, thank you very much, guys, and take care. Stay safe.